Hey guys, sorry I'm not there, but today we're going to do area of a triangle, and what we're going to do first is a little do now. So take a look. This is the material we covered yesterday. This is called um, ambiguous case. So the question is this: how many distinct triangles can be made if angle A is 30, side B is 12, side A is 8? Now it's multiple choice. One of those choices should jump out at you as being a very bad choice, but if not, you're going to set it up like we did yesterday. So try it out. So I come up with angle B to be, um, what do we got here? Rounded 49 degrees. So that's 0.75. And what we did yesterday was we made a chart, A, B, C. Angle A is 30. For this problem, angle A is always 30. It's given to us. So angle B, though, I found is a reference angle. So that's 49. That's my reference angle. So I need to find quadrant 2 angle, the supplement. So I'll just use calculator, 180 minus 49. We should get 131. And then finally, a triangle always adds up to 180. So we're just going to see if we can find the missing angles. This would be 101 and 19. And since I completed 2 columns, there are 2 triangles. And if they ask for specifics, this would be 2 obtuse. These angles are bigger than 90, 2 obtuse triangles. So that's that. That was yesterday's lesson. So today we're going to talk about area of triangles. And this is actually a formula. Now, in the past, you've always done area of triangles. They've always been right triangles. And you've used used areas 1/2 base times height. Well, now we're going to change it. And we have a formula that's given to us on our formula sheet. It's called K equals 1/2 AB sine C. And it's on the formula sheet. It'll be given to you for any test or quiz. So it's just something. Now, the trick is you have to know what the parts are. So if you were to look at a triangle, this is my normal standard triangle. Whenever they're talking about this AB sine C, it's always this pattern. It's always this pattern. And if you recall from geometry, this would be side, angle, side. It has to be this setup. Side, the angle in between, and the side. This is called the included angle. Side, angle, side. Has to be this setup. So we're going to use this formula, and we're going to try a bunch of problems. So this is right out of our book, and so this is for find the area of each triangle. The first one's to the nearest 10. And what I could do is I could draw a picture. It's going to be ABC. And I'm going to label what they give us. So they say side B is 14.6. Side C is 12.8. Angle A is 56. So that's 56 goes here. Side B is opposite, so that's 14.6. And side C is opposite, so that is 12.8. And if you notice, that's our pattern that we were doing. So side, angle, side. I don't care if they're called A, B's, and C's. I don't care. I'm looking for this pattern, side, angle, side. So I'm going to use my formula. K equals 1/2, whatever this is. So 12.8 times 14.6 times sine 56. And this goes in your calculator one shot. Punch it in. And you should get 77.4653. Round to the nearest tenth, one decimal place. So it'll be 77.5. And that's pretty much the formula. So let's try another one. Triangle PQR. All right, so the numbers are bigger. Well, big deal. Big numbers, big calculator. It's okay. PQR. All right, label the sides. P is 212. Q is 287. Angle R is 124. 212. 287. Angle R is 124. Now, I have the pattern side, angle, side. K equals 1/2 AB, right? That's my formula. I gotta use this formula. But now I'm just going to change the letters, and I really don't care about the letters because that's this pattern. So K equals 1/2 212 times 287 sine 124. Punch that in your calculator, one shot. And instead of a half, you might want to use 0.5. Type that in, one shot, see what you get. Now, let's see, I got 25220.98. Now, remember, the directions say to the nearest tenth. I need one decimal place. Now, that's going to bring this up, but that's going to bring this up. So it's going to be 25221. Now, that's the answer, but since it says one decimal, you better show one decimal place. And that's K. And K is just area. For some reason, it just called it K. All right, let's try it again. All right, exact value. Exact value. Now, when they say words exact values, you should be thinking special triangles and radicals. And I know at this point you're saying, we don't do radicals. Well, think back. So now it says, find the exact value of an equilateral triangle if one side is 40. All right, let's think about that. So equilateral means all the sides are equal, and they happen to all be 40. Now, I need an angle. So if I want this angle, you got to think back. If all the sides are equal, that means all the angles are equal. And you need to figure out how much that angle is. Well, 180 divided by 3, this angle is 60 degrees. So punch it in your formula and see what you get. Go ahead. But now I'm not going to punch in this sine 60 into the calculator. All right, so what I would do is do this part first. So punch that in. So 1/2 40 times 40. So you're going to get 800. And then sine of 60, if you recall, special triangles, 30, 60, 90. So it's 1, 2, rad 3. So the sine of 60 is rad 3 over 2. And this is my k, which is my area. And then finally, 2 goes into 800. So the answer is 400 rad 3. So that's what it is for radicals. If they said to the nearest tenth, you punch this in and you get 690 or something, 700, around there. Next one. Find the area of a parallelogram. All right, so it's a little different. Two adjacent sides, blah, blah, blah. 40 and 24. The measure of one angle is 30. All right, so I have a standard triangle. I have a pretty standard parallelogram. This is my parallelogram I usually draw. Looks pretty much like that. 40 is longer, so I'll put 40 on the bottom. 24 is shorter, that's why it goes on the side. The angle's 30. Well, this angle's acute, so I'll call that 30. Now, this is not a triangle. But what you need to do is think about this and say, actually, if I cut that right there, it's actually two triangles. Right? Here's one, and there's the other, and they're actually the same. So if I find the area here, just double it, you'll find the area there. Once you punch it in, get this area, double it, that's the area of the whole thing. Try it out. So my area of the triangle is 240. Well, parallelogram, double it, times it by 2. So the area of the parallelogram would be 480. And that's the basic formula. That's the formula they give us on the regions. And that's how we use it. And that's pretty much the end of it. Except, what if, think about this. What if they don't give you an angle? So what if they don't give an angle? All right. Let's think about this. If they gave me, some triangle, okay? Let's going to draw a triangle here. A 3, a 4, let's just make it a 5. Now, if they gave me a triangle like this, what I could do is a law of cosines first, right? Yeah, that would be good. Law of cosine first, find an angle, then use that angle and figure out which sides are on the opposite sides, That's a lot of work. That's a lot of work. All right. Hey, wait a second. This is a 3, 4, 5 triangle. I know that's actually right. Now, there's a reason why I picked this, because you should know how to do the area of a 3, 4, 5 triangle. Now, usually, it looks, you're used to seeing it more like that. All right, so let's just clean this up. Okay, and let's just put this normal. This is how you normally say it. So let's just put it back to normal. So I said 3, 4, 5. And if I said find the area of this 3, 4, 5 triangle, you would do base times height, 3 times 4, and divide by 2. 12 over 2. The answer is 6. That's the area of this triangle. Because I know it's a right angle. It works. But what if it's not a right? What if it's not? All right. And what if I don't want to do a low cosine? Because low cosine is a little tricky. Well, there's something called Heron's formula. Now, they don't spell it hero. They spell it as heron, but it's called Heron's formula. Sometimes you hear it called Heron's formula. All right. Now, before you go nuts, it's actually really easy. It looks horrible, but it's actually kind of easy. Heron's formula is this. Jumbo radical. The letter S times S minus A times S minus B times S minus C. All under this jumbo radical. And S is a semi-perimeter. It's called a semi-perimeter. And a semi-perimeter is just the perimeter cut in half. The perimeter divided by 2. That's called a semi-perimeter. And these are my values, A, B's, and C's that we've been using. All right, now you're like, that doesn't look any easier. Let's try it first. All right, first thing, let's find S. S is you add up the sides and cut it in half. So S would be 3 plus 4 plus 5, added up, divided by 2. All right, 9 and 3 is 12. 12 divided by 2. The semi-perimeter is 6. All right, so now this is what's going to be my parentheses here, right? 6. And then I subtract each side off of it. So it'll be 6 minus 3. 6 minus 4. 6 minus 5. And you're like, this is nuts. This is no way this is going to work. It works perfect. All right. So what I would do on my calculator, don't put the radical yet, because if they want it in radical form, you have to do it that way, or exact value, you'd leave it in radical. So I'm just going to do the guts, the inside, and just use the parentheses. One shot with the parentheses. So 6 parentheses, 6 minus 3. Close. Parentheses, 6 minus 4. Close. Open. 6 minus 5. So this is the inside, no radical, and it comes out to be a 36. And hey, the square root of 36 is 6. So by using this formula, Heron's formula, you get the area. So you might not be convinced. Let's look at another question. The accompanying diagram shows a triangular plot of land located in Moira's garden. Find the area of the plot of land, round your answer to the nearest 100 square feet. So they give us 3 sides. Now, if you don't like the Heron's formula, you could feel free to find like one of the angles and then do the formula. I'm going to use Heron's formula. All right, so one thing you have to physically calculate first. That's the S, which is called the semi-perimeter, right? So the perimeter over 2. So you got to add up these 3 sides. So add up the 3 sides, 125, 160, 135. And divide it by 2. And let's do that. 125 plus 160 plus 135. Enter. Divide by 2. Enter. 210. S equals 210. Big radical. Now, they do not give you this formula. They do not give you this formula. So this is a formula you'd have to memorize. It actually comes in handy when you're doing problems like this. If not, then you're going to do law cosines in an area. So it is what it is. So remember the formula was S parentheses S minus A, S minus B, S minus C. So we're going to throw these all in the parentheses. And it's not that big a deal because the calculator is going to do all the hard work. So it would be 210 minus 125, 210 minus 160, 210 minus 135. Goes in the calculator one shot. Do not put the radical on it yet. Just do all the inside. And you get monster number 6693750. We're going to square root this. And I get 8181.534. Bunch of decimals, right? One, let's call it. Now this says to the nearest 100 square feet. All right, not hundredth, 100. So that's ones, tens. I'm rounding to this spot right here. So 181 would turn to 200. So it would be 8,200 square feet. That's Hero's formula. And that's it. Okay, so you have a worksheet now, which is just like 5 or 6 of these area problems. There's an answer key that you can get the answers from, and on the back is your homework. Thank you. Have a great weekend, and I'll see you Monday. Bye.